Hello, everybody. Welcome to G4 Lab, and today we're going to have our first IB physics video, and it'll be about projectile motion, which is a part of topic 2.1. So, what is projectile motion? Well, that's a great question. Projectile motion is the motion of an object that is launched into the air. It can be released or thrown, and the only force acting on it is going to be gravity. And that'll be referred to as G from now on, and assume that the acceleration of G is 9.81 meters per second squared towards Earth. So how do we tackle projectile motion? Well, it can be modeled with the following four kinematic equations. The first one is the final velocity is equal to the initial velocity plus the acceleration times the time. The second one is that displacement is equal to the initial velocity plus the final velocity divided by 2 times the time. The third one is the final velocity squared is equal to the initial velocity squared plus 2 times acceleration times the displacement. And the final one is that displacement is equal to the initial velocity times time plus 1/2 times the acceleration times time squared. And we do not account for air resistance in problems where we use this kinematic equation. So it's also important to note that in projectile motion, since the only force acting on the projectile is gravity, we have to separate horizontal and vertical motion. And this is, in particular, this is because gravity only acts down, so it only impacts the vertical motion. And so because of that, horizontal motion will usually just be a constant velocity. And a neat little trick you can use to help solve projectile motion problems, is to create a table that lists all your knowns and unknowns. So you know exactly what to solve for, and that reduces the chances of making a mistake. And because gravity only impacts the vertical motion of projectiles, you can actually separate the table into two rows, one for horizontal and one for vertical. So the first problem is that a marble rolls across a horizontal table with a speed of 3.75 meters per second. If the table is 1.65 meters high, how far away from the edge of the table will the marble land? And for vertical motion, always assume downward is positive. So using the table trick, we know that the horizontal velocity is 3.75 meters per second. Vertical velocity initially is 0 meters per second because the table is horizontal. The acceleration is always g, and the vertical displacement is 1.65 meters because that's how tall the table is. And so in order to solve the problem, the unknowns we need to determine are the total time the marble spends in the air, and then distance it travels after rolling off the table. And in this case, we don't need to know the final vertical velocity of the marble, as you'll see. So we know that the horizontal motion of the marble has no effect on how long it stays in the air, and therefore to solve this problem, we need to determine how quickly gravity causes the marble to hit the ground. And we can use this kinematic equation to do that. So 1.65 is equal to the initial velocity times the time plus 1/2 times g times t squared. But then remember that the initial vertical velocity is 0, so then this simplifies to 1.65 is equal to 1/2 times g times t squared. Because for that initial velocity times t, well, anything times 0 is 0, so then we can just get rid of that component. So now we need to solve for t, and we just do that by rearranging the equation to isolate t squared, right? So 1.65 is equal to 1/2 times g times t squared. So then t squared is going to be equal to 2 times 1.65 divided by g, and then t is going to be equal to the square root of 2 times 1.65 divided by g if you take the square root of both sides, and then if you solve that, t ends up being equal to 0.58 seconds. So remember that the question asked for the distance of the marble traveled after rolling off the table. And we're given that the marble was traveling horizontally at 3.75 meters per second. And so we simply multiply that by the time the marble was in the air, which we just obtained, right? And 3.75 times 0.58, and that ends up being 2.18 meters. So that's our final answer. So we'll go over another problem. A ball is thrown horizontally from the roof of a building, 56 meters tall, and it lands 45 meters from the base. What was the ball's initial velocity? And we're going to assume that the direction it was thrown was the positive direction. So using our table trick again, we can see that the horizontal displacement of the ball from the base of the building is going to be 45 meters. Initial vertical velocity is 0 meters per second because it was thrown horizontally. The acceleration is g, and the building is 56 meters tall, so the vertical displacement will be 56 meters. So in order to solve the problem, the unknowns we're going to have to figure out are once again the total time the ball spends in the air, but then in this case we need to figure out the horizontal velocity. And also once again, we don't need to know the final vertical velocity of the ball for this one. So the overall process is actually going to be pretty similar to the last one. So the horizontal motion of the ball has no effect on how long it stays in the air. We already know that, right? And so to solve the problem, we just need to determine how quickly gravity causes the ball to hit the ground. And we can use the following kinematic equation to do that, just like last time. So 56 is equal to the initial velocity times the time plus 1 half times g times c squared. But then just like last time, the initial velocity is 0, vertical velocity, so then it just simplifies to 56 is equal to 1 half times g times t squared. So we need to solve for t now, and we do that by rearranging the equation to isolate t squared. So 56 is equal to 1 half times g times t squared, right? And t squared is equal to 2 times, oh, that should be 56. 2 times 56 over g, and then t is equal to the square root of 2 times 56 over g, and then t ends up being 3.38 seconds. So remember that the question asked for the initial velocity of the ball after it's thrown off the roof. And since the ball was thrown horizontally, the initial velocity is just going to be the horizontal velocity of the ball throughout the sequence. And thus, we simply divide the horizontal distance traveled, which is 45 meters, by the time we obtained earlier. And we get 13.3 meters per second once we do that, which will be our final answer. So for angular problems, the problems usually involve a projectile being launched at an initial velocity at a certain specific angle. And we know from before that the horizontal and vertical components, velocity, don't impact each other, right? And so to deal with this, we just apply trigonometry to separate out the horizontal and vertical components. And let's give it a try on problem number 3. So a soccer ball is kicked into the air at a velocity of 29 meters per second and at an angle of 37 degrees. So how far away will it first hit the ground, assuming we ignore air resistance? So using the good old table trick, we can determine that the horizontal velocity is 29 cosine 37. Why? Well, think of a right triangle, right? In the right triangle, our hypotenuse is going to be 29, right? And then the angle between the hypotenuse and the side directly below it is going to be 37, right? And the side directly below it, you guys can imagine is going to be the ground, right? Because the angle between the direction the ball was, or yeah, it was thrown, and the direction the ground, sorry, is going to be 37 degrees. That was given in the problem, right? So then to figure out the horizontal velocity, we just need to figure out how long the adjacent velocity to the angle, right? And so we know that adjacent over hypotenuse is cosine. So then our horizontal velocity is going to be 29 cosine 37. And then using similar logic, we can figure out that the vertical velocity will be the side that is opposite to the angle, right? And so then it's just going to be 29 sine 37. And in this case, we can actually be sure that the final vertical velocity is going to be negative 29 sine 37 meters per second, because the ball is kicked from the ground and it's going to land on the ground. Or in other words, the amount of time gravity the ball takes to reach its peak flight path, it's going to take that same amount of time to go back down to the ground. And because of that, because gravity is always, it's going to be 9.81 meters per second, the magnitudes of the final and initial velocity are going to be the same. And yeah, so to solve this problem, the unknowns we're going to need to figure out are the total time the ball spends in the air and the horizontal distance it travels. So to solve this problem, we just first need to determine the time the ball takes to reach the ground. But then we know that the ball is being kicked from the ground and it's going to land on the ground. So then, as we talked about earlier, we can be sure that the ball takes the same amount of time to go from ground to peak and then back to ground. And thus, we only need to figure out how long the ball takes to decelerate to 0 meters per second, or in other words, how long it takes to reach the peak height, and then double that. So the t is equal to 29 times sine 37 divided by 9.81. Remember, 29 sine 37 is the initial vertical velocity, and to figure out how long it takes to decelerate, we just divide that by 9.81. And we get to reach its peak, it takes 1.78 seconds. And so 1.7, yeah. And so the total time the ball spends in the air is going to be double that, since it needs to come back down from the peak, right? And so 1.78 times 2 is 3.56. Now we have the total amount of time the ball stays in the air, right? And so the problem asks for how far away the ball hit the ground relative to its starting point. Or in other words, the horizontal displacement assuming the ground is flat. Thus, to get our answer, we just multiply the time we got by the horizontal velocity, which was 29 cosine 37, right? And we end up getting the displacement as 82.5 meters. So just a little review. In projectile motion, horizontal motion and vertical motion do not affect each other because gravity only acts downwards. Even in projectile motion with angles, we use trigonometry to separate out horizontal and vertical motion. And either way, the table method is going to be a great trick to organize your horizontal and vertical components. Yeah, thanks for watching. Next video, we're going to go over uniform accelerated motion. And please be sure to check out our IB Comp Sci and IB Biology videos as well. Bye.